So in today's session, we are going to talk a little more deep about vectors.
Mhm.
So we already know those physical quantities which has magnitude alongside
Direction.
dash.
Mhm.
Let's understand with an example. So I'm taking a very basic example. You can simply answer it. So suppose there is different lanes.
Mhm.
And there are different positions. Let's say A position. This is the position of some shop. B position. This is the place where friends live. And C position where you live. So suppose your friend asks from you that what is the location of the shop, and he or she called you and asked you to share the same. So just tell me, how will you explain your friend that where is the shop, depending upon the location where he or she is residing? You will simply say, go straight, take the necessary turn, and then again take the turn. You will get to the shop. This is how you are supposed to say it. So
Mhm.
how will you say it? Suppose wherever you are living, just go straight, take the first left, and then go as per the lane diverts. So
Mhm.
ultimately, you will reach the shop A. So this is how you are going to explain in terms of directions. Similarly, if we talk about the same in physics, we don't explain it this way. Like for example, suppose if I consider that whole things lies in a coordinate system where I would say that all the points here A, B, C will have different locations, will have different coordinates to be precise. I can
Mhm.
call this as one as x1, y1. I can call this as x2, y2. I can call this as x3, y3. So these coordinates with respect to the origin are the specific coordinates unique coordinates? So we can also tell the same thing that you need to move to the x1, y1 coordinate in order to reach the shop.
Mhm.
That is one way of explaining that in which direction and how you actually have to move. Now, let's consider the same for case of actual location we actually describe for different particles. Like for example, when we are sharing our location or when we are talking about a specific particular place near our um, place where we are living. So what we used to do is we used to share the location directly. So when we are sharing the location, again, we are actually sharing these coordinates. So
Mhm.
how Google is doing all these things? For example, suppose this is Earth. So Google has divided this whole Earth into a coordinate system, and that too a coordinate system which has all the three axes x, y, z, like that. Like for example, if you are sharing the coordinates of this point A, You will be sharing x1, y1, z1.
Mhm.
So can I say this x1, y1, z1 having unique coordinates throughout the Earth
Yeah.
as per the coordinate system? So
Mm,
when we are talking about vectors, we're not only talking about the magnitude, but we also talk about the direction. So the direction is something which is given by the angle
mhm.
of this point, which is made with equator.
Mhm.
We can say equatorial plane.
Mhm.
So I have already mentioned the same thing that when you are sharing the location of a point, so if you open the location, you will ultimately see that it shows the direction with the help of angle. So that angle which we are sharing, it is the angle made by the point with the equatorial plane.
Mhm.
So this is the major application of this vector, that how
Mhm.
we are using vectors and how we can talk about it to be precise. So magnitude is something which is represented by the same phenomena, like the squares or the coefficient of a given vector in each direction x, y, z. Whereas direction is something which can be represented in the form of I, j, or k cap, or you can say, so this is the main reason of having vectors in our curriculum. Let's talk more about it. So the second thing came is representation of vector. That how we actually represent vectors. So a very basic idea. Again, we'll consider a Cartesian plane or a coordinate system having all the three coordinates. We assume that there is a vector which is supposed to be drawn like this. So always remember, a vector is something which is represented by arrowhead.
Mhm.
I'm considering three directions, three dimensions here, but in most of the cases you might be dealing with two dimensions. But if you understand this three-dimensional thing, two-dimensional will automatically be understandable.
Mhm.
So if we look at this particular vector in all three dimensions, then I say that this vector must be along all the axes, along all the planes, like how, let's see. So here you can observe that this vector we have, if I consider it to be in all three planes, it is going to look like that.
Mhm.
So this point, can I write this point as x1, y1, z1? Now what this x1, y1, z1 are? The x1 is representing this particular line,
Mhm.
whereas y1 is representing this particular
Mhm.
line, whereas z1 is representing this particular line. Also, in order to get the position of this particular point P, this x1, y1, z1, these are the lines which make some angle with the different axes as well. So I can assume this is alpha, this is beta, and this is something gamma, I would say.
mm,
So these are the angles made by the vectors with a given axis. Now what these angles are called? These angles, alpha, beta, and gamma, are known as direction cosines. That is the important part. We call them direction cosines. You might see this word used by your class teacher in the upcoming classes, which are generally represented or given by cos alpha, cos beta, and cos gamma. So if we are going to represent this P point in the form of vector, we'll represent P as OP vector, which is nothing but x1 I cap, y1 j cap, z1 k cap. Also, if we want to find the magnitude of OP vector or given vector, so this is something which is given by OP vector mod, or you can say modulus. It is nothing but x1 square, y1 square, z1 square.
mm,
So again, we already saw this in some of our previous classes. There is something, it's called modulus of OP. This is something which gives us magnitude. Similarly, if we want to represent the direction, the direction is something which is given by cap. So I already explained you that a vector is something which has magnitude as well as direction.
mm,
So that direction thing is generally given by cap for such kind of vectors only, which is represented in ijk cap form.
mm,
OP cap is going to be x1 I cap plus y1 j cap plus z1 k cap over x1 square, y1 square, or z1 square. This is how the direction of a given vector is given,
mm,
and this is how the magnitude is given. So we'll certainly see so many questions in your classes based upon these representations, and this is how you should look about it.
mm,
Next, we have to talk about angle between the two vectors. Angle between two vectors. So we also talked about this one. So suppose there are two vectors lying on a straight line like that. This is vector A, I assume. This is vector B, let's say. So if we want to find the angle between the two vectors,
mm,
the first step we need to do is, alright, one more thing. Suppose this is a vector. So this is the part which we call tail, and this is the part which we call head. So in order to find the angle between the vectors, what we need to do is we need to either join these two vectors tail to tail or head to head. So there are two possible ways. tail to tail or head to head. Now, what does it mean? Although we already did it. So vectors are something which can be moved into the plane anywhere parallelly, upside down, right, left, without any issue. So in order to get the angle between these two vectors, what can I do is I draw the B vector as it is, just like it is, and I shift the position of vector A and put it close to vector B. So this is vector B. So I'm just moving the position of vector A. So I can make this vector A like that, right? So now we can see that the angle will be defined by this theta.
Mhm.
Similarly, we can also create the same by changing the position of the vectors like this. So I'm shifting this vector B upward and this vector A a little downward. So
Mhm.
here also the angle between the vectors is given by the point where their head joins. So again this angle is going to be the theta, that is the angle between the vectors.
Mhm.
So that is the very basic thing, and we need to understand this fact first in order to define the direction of any two positions.
Mhm.
All right. So suppose it's given that there are two vectors. One is towards east, one is towards north. So what is the angle between the two vectors?
90.
90. But the question never says that the particle has moved this way or the angle is given this. You always have to figure it out by changing the position of the particular particle. All right. Suppose now the question says a particle traveled 300 meters towards east and then he took a left turn and traveled 400 meters towards north. So in this example, if you see, the question says what is the displacement? Although we know how to find the displacement, but in order to do so, we can use the resultant or the displacement formula as well. So here the displacement is something which is going to be given by this relation a
Mhm.
square plus b square plus 2ab cos of 90, because the angle between the two vectors is supposed to be 90 degree. So
Mhm.
when we are actually applying Pythagoras theorem, we are not applying Pythagoras theorem. We are actually applying triangle law or parallelogram law to find out the resultant of the two vectors.
Mhm.
But it seems to be that we are applying Pythagoras theorem because the cos 90 is something which is zero. If there is
Mhm.
any angle between these two positions, displacement is not going to be zero at all.
Mhm.
So here, in this case, we'll get displacement as 500 meters from the initial position. But always remember, we are not only getting displacement using Pythagoras theorem, but by using the resultant relation which we used in the previous classes. Let
Mhm.
me just give you a question and you can tell me whether it is going to be how it is going to be solved or what are the given things. So the question says that there are four different vectors and you have to find the angle between all the given possible vectors like that.
Mhm.
So the first is this vector A, second is this vector B, third is this vector C, fourth is this vector D. This angle is supposed to be 70 degrees And the question is find angle between each vector. That is between AB, between BC, between CD, and between DA.
Mm-hmm.
So you have to figure it out and tell me what are the given angles between the vectors. Like, let's start it from the beginning. Although you can take a minute and try it out. Remember the key condition in order to find the angle between any two vectors, these vectors should be either joined tail to tail or head to head. If we are
Mm-hmm.
not making them join tail to tail or head to head, we won't be able to find the angle. Or
So
whatever
then,
we find, that's not going to be the angle.
hmm
Yeah,
so um, you can't find C to D, right? Because it's tail to head.
yeah,
Um, and then same with B to A.
exactly.
Mm.
So how we are supposed to find it out? So there are the few things. First, vectors either shifted into the plane upside down in order to find out the angle between them. So in order to do so, what we can do is we can shift the position of any of the given two vectors. There are two ways. Either I shift the position of A, either I shift the position of B. So if I shift the position of A, how would it look? This was B, and I
Mm-hmm.
shifted the position A like that. So the angle between vector A and B is going to be given by this angle.
Mm-hmm.
So if you look at carefully, if this angle is 70, this angle is also going to be 70 degree. So can I say that between A and B, the angle is 70 degrees? Can I say that?
Why would that be 70?
Because the vector seems to be parallel to each other, A, B, C, D.
Oh, okay.
And by using the properties of parallelogram, we can find out all the angles by just having one angle.
Mm.
Similarly, between C and B and C, we can simply see the angle between B and C is going to be what?
Um, also 70.
Yes, also 70. Because this is 70, so this first is going to be 110 degrees. And again, this second is going to be 70 degrees. All right. So when we talk about finding angle between C and D, what can we say?
That one's also 110.
Just think again. So D is something which is drawn like that. And in order to find the angle between C and D, I have shifted the position of C. So the angle between the vectors is given by this. So again, it is going to be what? It is going to be 70.
Mm.
And also, as I mentioned, that these all vectors are parallel.
Mhm.
So if the vectors are parallel, so the angle between them won't change. And here also you can see the angle between AD is also going to be 70 degrees.
Mhm.
We are just trying to find out the angle between the given vectors, and this is how we are supposed to do so.
Mhm.
So this is one such few cases where we actually using angle to find out the resultant. So this is how angle is being observed. So let me just give you a very simple question. And the question says, you have given a vector A as 2 I cap minus j cap plus 3k cap. And the question is, find a unit vector parallel to given vector A. Now what does it mean? So here there is a term called unit vector. So whenever there is something like that is there in the question, that unit vector is something which is given by A cap. This is the another name of cap, you can say, that is unit vector. So A vector or A cap is going to give us unit vector. So we'll try to figure it out what this A cap is. So we already know that A cap is something which explains the direction. So we can write it as vector divided by the magnitude. This is something which will going to give us cap, and this is something which we know now, which we called unit vector. So you'll be observing this term again and again in almost you can say different chapters apart from this one also. So we need to understand that what it is. So unit vector is something which represents the direction as well as which represents what is the magnitude of one unit of given vector. That
Mhm.
is also called unit vector. So A vector is given by 2I cap minus j cap plus 3k cap. Whereas the magnitude of A vector is given by 2 square plus minus 1 square plus 3 square. So A cap is going to be, we'll write 2I cap minus j cap plus 3k cap. And what about the magnitude? 9 plus 1, 10. 10 plus 4, 14. That is going to be something like that. So this is how we are supposed to find out the unit vector for any given vector we have.
Mhm.
So this is another such case where we were actually finding out the unit vector. All right, let's move ahead. Next comes addition of vectors. After the addition part, we'll also talk about the subtraction part. So addition of vectors are a very basic, very simple thing. Just assume there are two vectors. Vector A is given by Ax I cap, Ay j cap plus Az k cap. So here you can simply see that the vector has all the components in different axes. Similarly, we assume that there is another vector Bxi cap, Byj cap, Bzk cap. So when we need to add these two vectors, we simply write A plus B.
Mhm.
So when we are adding vectors, we just need to add vectors directly without any problem if they are given in this form.
Mhm.
So ax plus bx, I cap, ay plus by, j cap plus az plus bz, k cap. So this will give us the result of the two vector addition. If we try to apply the same in a question, so I guess we can answer it. If the vector A is given by I cap minus j cap plus 4k cap and B vector is given by 2I cap minus 2j cap plus 6k cap. So can you tell me what is the sum of these two vectors?
Yeah. Um. So I cap plus no, sorry. I wait. Is it just
If there is nothing with I cap, what we can assume? We can assume 1.
mm-hmm.
So 1 plus 2,
Mm-hmm. And then
3
I
I
cap
cap.
side. Oh, okay, yeah. Three
Here
I
we
cap
have, yeah,
minus, but does it become plus? Because it's minus minus.
yeah, it's minus and minus, so we'll add it. So minus 1, minus 2 will be
Mm-hmm.
minus 3j cap.
Mm-hmm.
Similarly, 4 plus 6.
K cap. 10K cap.
So this is how we are adding the vectors when we actually have vectors given in their original form. As simple as that. But what if they're not given in their simplest form? For example, there is a block, and on that block there are two perpendicular forces. 8 newtons and 6 newtons acting this way in the given system. So the question is find net force. So how we are actually supposed to do so? So here in order to find net force, we have to use different laws of vector addition, and the laws are given by the laws are of following types. Laws of vector addition. So the first law we have is triangle law. We already seen that how we actually apply this law, but today we are going to talk about that how we got this relation, like a square plus b square plus 2ab cos theta. Similarly, we have another law called parallelogram law of vector addition. Last but not the least, we have polygon law of vector addition for more than two vectors to add in a same plane.
Mm-hmm.
So in all the three laws, we are going to add vectors considering there is some angle between the vectors and those vectors has some magnitude. So let us directly go into the equation part, that how we got the equation. In order to do so, what we do is we'll assume that there are two vectors A and B, like that.
Mm-hmm.
And these two vectors has some angle between them. So what we are going to do is we're going to represent them in the form of two sides of a triangle, joining them in such a way that head of the given vector will be joined from the tail of the another vector. So, but the thing is, we cannot change the angle between these two vectors in order to find the resultant. We'll simply shift the positions parallelly in the plane, but we are not going to change the orientation. That is the important part. So here I shift the vector A, I'll keep the vector A this way only, and I'll shift the position of vector B like that. And this angle is something which we can represent using this line, because this is what the angle is, right?
Mm-hmm.
So the triangle law says when two vectors representing both magnitude and direction in a given plane in the form of two sides of a triangle, then the third side of the triangle, which will be there, this side of the triangle will give us the resultant, joining in the opposite sense. That is again important. So here you see, if I mark this as O, A, and B. So here
Mm-hmm.
in triangle OAB, can you see that the third side of the triangle is actually giving us the resultant? This is what the law also says. But what about this ODB triangle? In order to find out the value of R, we need to find out the value of AD and BD.
Mm-hmm.
So let's do that first. So this is my B vector. This is angle theta, and this is something we call BD, and this is something we call AD. So this VD is going to be vertical component of the given vector V, and this AD is going to give us horizontal component. Now the question is, how can we find these two components? By simply using trigonometry. Also, I told you this thing that the component along with the side theta is always a cos component. So here this is nothing but B cos theta, and this is something B sin theta.
Mm-hmm.
Did you remember
I think so, yeah.
how we actually get it?
Um, no.
By using the trigonometry. So V is something which is representing hypotenuse of the right angle triangle, because VV is perpendicular or adjacent, and this is the base. So if we apply the cos in this
Oh,
triangle, so
are you
cos theta
talking
is
about
going to be,
like the cos is adjacent over hypotenuse?
yeah.
Okay, yeah, I know those.
So we are actually going to apply the same, and here we get cos is nothing but AD by P.
Mm-hmm.
Not exactly. So we can write this base by hypotenuse. So this base AD is going to come out as B cos theta. We
Mm-hmm.
talked about in the previous classes. That is going to be B cos theta. Similarly, this BD is going to be B sin theta. So this is how we actually obtain the values of these two sides. Now, in order to find out this OB, what we can do is we'll simply use the Pythagoras theorem in the whole triangle OBD. Now look at it. We'll see that how we actually got the result. Applying Pythagoras in OBD triangle. So here OB square is going to be OD square plus BD square. Can I write this?
Mm-hmm.
Now we simply substitute the values. So this OB is nothing but R. That is what we need to find. OD is something I can write A plus B cos theta. That too whole square. BD is nothing but B sine theta. Again whole square. So how we are supposed to solve this? We have to simply apply A plus B whole square. That is going to be A square plus B square cos square theta plus
Mm-hmm.
2AB cos theta plus V square sine square theta, like that. So
Mm-hmm.
A square plus B square is there in both the terms, this term and this term.
Mm-hmm.
So I'll be taking it out as common. So inside we left with cos sine square theta plus cos square theta plus 2AB cos theta. So
Mm-hmm.
R square will come out as A square plus B square plus 2AB cos theta, because sine square theta plus cos square theta is nothing but 1.
Oh.
So R square is given by whole square root A square plus B square plus 2AB cos theta. Now
Mm-hmm.
what is this? This is the magnitude of the resultant. It is nothing but it is the magnitude of resultant. Whenever we are talking about the direction of resultant, we can use tan theta to find out the direction.
Mm-hmm.
We can also mention the same thing. So direction is something which is given by angle made by resultant vector with one of the given vectors. So in order to find out the direction, what we can do is we can actually find out that this angle, which we can name as alpha, beta, whatever you feel like.
Mm-hmm.
So in order to find out this beta, we can use whichever of the given trigonometric function, tan, cos, sine.
Mm-hmm.
But we'll always prefer that whenever we are finding the direction, we should use those vectors which are already given in the question instead of using this magnitude of resultant itself, because this is
Mm-hmm.
something we found, so we want to use it directly. So that is what we need to understand here. Now we can do this question, this one. Let's see what we got. So the same example, there is an object which is experiencing two perpendicular forces. One is 8 Newton in horizontal direction and another is 6 Newtons in vertical direction. So the question says find the resultant force and the direction of resultant force. Simultaneously, we have to find that. So how can we do so? First of all, we need to figure it out that what is the angle between the two applied forces or the two given vectors. What is the angle between the two given vectors?
90.
90 degree. That is quite easily visible. Similarly, we can assume A is something which is 8 and B is something which is 6, right?
Yeah.
So we know that their net effect, that is resultant of these two vectors, must be visible in this direction, right?
Yeah.
So this resultant must be making some angle as well. So I'll consider this angle as beta. So we have to find the magnitude of this resultant as well as this angle in order to find out the magnitude as well as direction of this resultant or the net force acted because of these two perpendicular forces on the given object. So
Mm-hmm.
how can we do so? We can simply apply vector resultant relation. So we know R is nothing but A square plus B square plus 2ab cos 90 it is going to be, because the angle between the vectors is 90 degree. And what is the value of cos 90?
Mm. Is that just one?
It's 0.
Oh.
Cos 90 is 0. So R will going to come out as 10 newtons. So here we got that the resultant has the value 10 newtons by simply applying the relation. But at what angle, at what direction it is acting? We also have to find out that. So
So
as we
wait, the
discussed,
thing you did
yeah,
is you did a squared plus b squared, but then you said
yeah,
cos 90 is 0, and then oh, okay, never
mm,
mind, never mind. Yeah,
yeah, because this whole thing is going to become 0.
okay.
But in some other cases, when the angle is there, we cannot make it 0 directly. We have to solve it for the given value.
Mm-hmm.
Similarly, in order to give the direction of this resultant vector, what we can do so is, as I told you, that vectors are something which can be moved into the plane anywhere without changing its direction.
Mm-hmm.
So can we shift the position of the given vectors like that? Like this is 8. I'm shifting this 6 Newton vectors little ahead like this. And the resultant vector like that. Which is, this is the angle which I actually need to find out. So here, when I need to find out the angle between these two vectors, angle between the resultant, or you can say the direction of resultant, will be simply using tan theta. In this case, it is going to be tan beta, and tan is something which is what?
Um, opposite over adjacent.
Can I write it as 6 over 8?
Yeah.
The tan beta is something which is coming out to be 3 by 4. So if the value is not given, we will simply write that tan inverse 3 by 4 is going to give us the direction of the resultant. That's it.
When do you write it that way?
Because we don't have the value of tan beta, that at what value tan is 3 by 4. This is something which we don't know. So we can
Okay.
write it in the form of inverse. So tan inverse 3 by 4 is something which is the angle between the resultant and the given vector.
Mm-hmm.
So this is how we are supposed to write it out. So that's how we need to think. Similarly, suppose if there is another question, and the question says that there are multiple forces acting on an object in different directions, like that.
Mm-hmm.
One force of 3 newtons acting at 30-degree with x-axis, another force of 5 newtons acting at 60 degrees, another force acting at 45 degrees of 4 newtons. So the question is, what is the net force? Find net force acting on the block. So how we are supposed to do so? In order to do so, we need to find it out that what is the directions of each and every component. Like for example, this first vector 3 Newton must have directions, must have component along x-axis as well as along y-axis. What is the component along x-axis? We already discussed the component along x-axis or the component along theta is cos component.
Mm-hmm.
So it is going to be 3 cos 30 degree. Similarly, along y, it is going to be 3 sine 30 degree. So basically,
Mm-hmm.
what we did here is we just split the component of a given vector in the two dimensions, x as well as along y.
Mm-hmm.
Similarly, if I talk about four Newton vector, so I can say that it has two components, just like this 3 Newton vector, and the component should be 4 sine 45 and 4 cos 45, like that.
Mm-hmm.
Similarly, this 5 Newton again has some component. It is going to be 5 cos 60 along vertical, and it is going to be 5 sine 60 along horizontal.
Mm-hmm.
Now, I guess it is pretty much visible that what are the forces acting in what are the different directions. So, along positive x-axis, only 3 cos 30. Along negative x-axis or negative horizontal direction, 4 cos 45
Mm-hmm.
plus 5 sine 60. Similarly, in positive y-axis, it is going to be 4 sine 60 45 plus 3 sine 30.
Mm-hmm.
Similarly, along negative y-axis, it is going to be 5 cos 60. So these are the forces which are acting on the particle.
Mm-hmm.
Now, how we are supposed to get the resultant force? In order to get the resultant force, what we'll do is we'll solve forces along x-axis and y-axis simultaneously differently. So see, the F net along x-axis can be written as F of positive x minus F of negative x. Like whatever total force is acting in the positive x direction should be subtracted from whatever force is acting in the positive x-axis as it x direction. So what can I write? 3 cos 30 minus
Minus 3 sine 30. Oh, sorry, 4. Yeah.
plus 5
Mm.
sine 60.
Oh,
You just
yeah.
have to figure it out that what are the forces acting in the given direction. So 3 cos 30 is 3 by 2 minus 4 cos 45 is 4 by root 2 plus 5 cos 60 is sine 60 is root 3 by 2. So 5 root 3 by 2. If we solve it, we'll get the value. Similarly, we find the same in the y-axis, so it is going to be f of positive y minus f of negative of y. So f of positive of y is something sine 4 sine 45 plus 3 sine 30.
Mm-hmm. Minus 5 sine. Was it 5 sine 60?
5
No, it
cos
wasn't
60.
60. Right.
5 cos 60, not sine.
Yeah.
So when we solve this, we'll get the answer. So 4 over root 2 plus 3 by 2 minus 5 by 2. You solve it, you get the value in different axes. When you get the value in different axes, what you need to do is again apply the resultant formula. It is going to be fx square plus fy square, and we know what is the angle between fx and fy, like x and y, it is 90 degree. So again we'll write the values in these two in this relation, and we'll get the value of resultant, the net
Mm-hmm.
vector out of the four given vectors. So this is something we actually called polygon law, because here we are solving vectors, more than two vectors at a single time, by considering or by breaking them into their component form. So that is important. So this is how we are supposed to solve these things. Although there are two more things lies in this particular topic, that is dot product and cross product. Although we have seen it a little bit, but I want to discuss it again in order to have a better understanding of this topic. That is the last part of this vector thing. So we'll talk about that also in the next class.
Mm.
Until then, these are the topics that are needed to be discussed.